Hey guys, and welcome to the Tables 101 course at Nine's Technical Institute of Roblox Studio Code. Somewhere on the screen I'll also put a counter for how many times I say the word table, just for fun, because tables are essentially the core of complex little code and are all over the place. So why should you learn about tables anyway? Well, let's look at some examples of how I've used tables in the past in my own project, Evotype. First, we'll check out the code for my NPCs. While it may not look like it to the untrained eye, basically everything to do with these module scripts is entirely based around tables, and none of it would be possible without the flexibility that tables provide. If we test the game, we can see the NPC himself, Billy-san. Now Billy-san here likes to wander around, but if you approach him, he runs at you and attacks you. You can block him and whatnot, and he even has the ability to sprint and dash, though dashing hasn't been fully implemented yet. He can theoretically do anything that any other player does, using the same exact code that players do, thanks to the wonders of tables, metatables, and how I have this system set up overall. So tables are cool and all, but what exactly are they anyway? Well, let's get started on a script that we'll insert into server script service, where we'll dive into the specifics. And well, there's a lot of different ways that you can create and edit a table, but we'll start with what is known as an array. You create tables using curly brackets like so, and in an array table like this one, you can insert any number of values of any kind, separating them each with commas. The key thing with this table we created that you can't really see from the code, however, is that it contains number indices for each of the values specified. For example, the first value corresponds to an index of 1, the 5 value corresponds to an index of 2, and so on, counting up from there. The index, in this case, is essentially like the numbered position of the items in the table. Indices are also sometimes referred to as keys. Now let's get to the dictionary tables, and this is where it gets fun. For a dictionary-style table, you can actually specify specific key-value pairs rather than just having ordered numbers. To prove a point though, I'll actually recreate the same table we had earlier in dictionary form, and it will actually function in the exact same way, creating the exact same table. This sort of shows what the sum table variable we created above actually looks like from under the surface, displaying the actual indices that we can't see just from creating it. But we can also take dictionary tables further than that, using values other than numbers as the indices or keys. For example, we can put strings in the brackets, or if the string has no spaces and starts with a letter, you could even put it without the bracket and it works the same way. To separate individual key-value pairs in a dictionary table, you also have the choice of using either commas or semicolons, so you can use whichever you prefer. Though the really cool thing about dictionary tables is that you can actually put a dictionary table inside another dictionary table. And if you didn't notice, I even used the previous table we made as the key for our inner table. Most of the time, you wouldn't ever need to use a table as a key, but you can literally use any type of value, including a function or a part. The same goes for the values as well. As you can see here though, we're able to create tables inside tables inside tables, and we can keep going on forever in theory. We can also put array tables inside dictionary tables inside array tables, or really anything you would ever want. But now let's see what these tables actually look like using some super fancy functionality of the output window that didn't exist when I started developing. Be grateful, it's amazing. If we print these tables, we can actually see and expand them in the output and see everything there is to see in the tables. Looking at our first two tables, you can see that both the array method and the dictionary method, with ordered numerical keys, do in fact create the exact same table. Looking at our final one, you can see just how complex a table can get if you really want it to. The one downside is that you apparently can't expand the tables that are in the keys of other values, which is fair to be honest. But how can you actually access the values in these tables? Well, let's let the AI explain this one, since I apparently took too long to think about it and AI got impatient. As you can see, you simply use square brackets on the table and put the key, and it will return the value associated with that key in the table. So if we went back to our first table, we can index it with the key 1, and that will give us the first value in our array style table. There's also another way you can access the values inside a table too. Given that the keys are strings and don't break any of the same rules as in making variable names, you can actually simply use a period like is shown here, putting the string key afterwards. If the key is anything other than a string, or if it doesn't follow the same criteria for making variable names, then this method won't work and you need to use the brackets. This is really useful for creating syntax that looks the same as working with parts and other objects in Roblox. And using the same general syntax, you can also change the values as specific keys in a table simply by using the equals symbol and setting it like a variable. You can also use the same alternative syntax I mentioned earlier to set a value using a period as well, and you can even create entirely new key-value pairs in a table using the same syntax as well. This means that you can create an empty table and then add key-value pairs individually later on if you wanted. The next way of changing values in a table has to do more with array tables only, and it's through using table.insert and table.remove. Table.insert adds values at the end of the array, and table.remove removes values at a specific index. For example, if we created a new empty table, we could use table.insert to then insert a new value into it at the last index. Though, if you wanted to insert a value into an array table at a specific index, you can do so by adding an additional argument to the table.insert function between the other two, which specifies the index to insert the value in, pushing other values up one index as necessary to fit it in. For example, if we inserted another couple values, but then on the last one specified to insert it at the key 1, then it would push the other values to the right so as to fit it in, which you can see when we run the code. You could also use the same method to insert a value somewhere in the middle as well. So let's go more into depth on table.remove. It's sort of like the inverse function of table.insert if you're familiar with that math terminology. But basically, it just does the opposite of table.insert and removes a value from a specific index, shifting others to the left to fill that gap. If we remove the first value, we can see that the other two then move over to fill the space. If you wanted to remove a value based on the value itself rather than its key, like if, for example, you didn't know what index it was at, you could use the table.find function to then find that index and remove that specific index. We'll insert a new value just to fill up the table again, and then we can actually run table.remove and add table.find as a second argument, searching the same table for the value we just inserted. As we can see, that specific value is then removed. But there's an issue with this single line method, and that issue comes up if table.find doesn't actually find the value and returns nil instead of the index. I originally thought that doing this would give an error, but it actually turns out it doesn't, as you'll see in a second. Table.remove also only works for array structured tables and doesn't work for non-ordered numerical indices. But if we were to insert a new value again, print the table, and then find the index for that value using table.find, we can then check if found one isn't nil using an if statement before actually trying to remove that index. If we tried removing it again this time, but now using our previous method of using table.remove and table.find on the same line, I originally thought it would give me an error for putting nil as the second argument of table.remove, but it actually instead just defaults to removing the last value instead, which is almost worse since that's unlikely to be what you intended to do and could easily go unnoticed if you're not careful. Now let's get to the fun part, for loops. We won't cover for loops with number ranges, since those aren't related to tables really, but I'll cover all the methods of looping through the values in a table and running code for each key-value pair. To display the functionality of a basic for loop, we'll create a new table that might function as storage for a player's in-game stats, for example. We can then print what that table looks like at the start of the game. After that, we'll run a for loop by typing it out like I am through the stats dictionary we created. For anyone who's already familiar with for loops, you may have seen the pairs or ipairs being used here, but thanks to recent updates on Roblox, that's no longer really needed. There will be more information on that posted in the description too if you're interested though. Either way though, everything inside this for loop will run once for every key value pair inside stats dictionary, changing the values of I and v to be the key and value associated with that key respectively. If we print both of them, we can see that it shows all the stat names on the left and their corresponding values on the right, even with the table we have for health. You can also get almost the same functionality using the same syntax but putting pairs around the table you want to loop through, and this is syntax that's more familiar to longtime Lua users since it was the norm up until now. As I'm writing here, the I and v are actually sort of like variables, meaning you can actually name them whatever you'd like, and the code works the same. For that reason, I recommend naming them in a way that makes sense contextually, as it makes the coding experience flow a bit easier. The difference between using pairs and not using pairs is actually pretty minimal and only really matters in very specific cases, such as if you had a table that has both ordered numerical indices and specific non-numerical keys as well, which you wouldn't ever really use anyway. Using a for loop without pairs is known as generalized iteration because it's essentially a combination of using pairs and ipairs, and thus works essentially the exact same for a table that's explicitly array only or explicitly dictionary only. So how does ipairs work then, since I'm already talking about it? Well, if we loop through our same stats dictionary using ipairs, you'll notice it actually doesn't print a single key value pair. This is because iPairs specifically only loops through array-structured key-value pairs that are numerical and ordered, and was for a while the norm for an array-style table. We can explore iPairs a bit more if we create a new array-style table again and run an iPairs loop through it. As you can see, when we print each key-value pair, it loops through all the values in our array just fine, and just as we would expect a generalized iteration to do as well. If we made the dictionary equivalent of this array table as well, it would still function the exact same way, further proving that array tables are just dictionary tables in disguise. But there's one key distinction to note about iPairs, and that's that it will stop if there's ever a gap in the number indices. For example, if we made a copy of our dictionary array table from earlier, but set the key of 3 to nil, or even just removed it entirely, which has the same effect, then when we loop through that table with iPairs, you'll notice it actually stops at the second key value pair, and doesn't ever make it to 4 or 5 because they don't come directly after 2. In conclusion though, you can basically just not use pairs or iPairs and get by just fine if all of this long explanation was just confusing to you, so don't worry too much about the specific details. The confusion of pairs and iPairs is largely the reason why generalized iteration was added to Roblox's modified Lua, or at least I would assume that's why, though I only recently learned that it exists. Anyway, that's it for this video, and I hope this video gave you a good explanation of almost everything to do with tables, other than a lot of the other table functions I didn't include. If you want to learn even more about tables and the different functions that you can run on tables, check the documentation link in the description, because it has loads of info for you to check out. There's also documentation on metatables and meta methods too, if you want to Google that if you're interested. Finally, if you have any coding questions or questions related to Roblox Studio development in general, feel free to join my Discord server in the description as well, to ask them in the appropriate question channels there. Additionally, if you would like access to the scripts and files from this video, as well as all my others like my inventory or shop series, feel free to become a member either on YouTube or on Patreon for $2.99 a month for access to that and more, or to purchase an even higher tier membership for extra special benefits like scheduled one-on-one tutoring with your projects. Nonetheless, thanks for watching and I hope you enjoyed the video.